Hi everyone, we're Team 2, and today we're going to continue on our presentation with the foundation where the Cadet Chapel was built. Remember in the previous presentations we told you guys that the Cadet Chapel locates in the North America, Colorado Springs, USA? Well, let us give a more specific explanation on this topic. The USAFA is located in the center of Colorado, located to the north of Colorado Springs. Let's zoom in even further. A map outlining the boundaries of the USAFA is shown here. This is the site map of the Air Force's Academy. The Air Force Academy has many facilities like a golf course, an airfield, and a stadium. But the Cadet Chapel is located in an area called the Cadet Area, where students' educational facilities are gathered. The Cadet Chapel is at the heart of other facilities such as guest houses, hospitals, dormitories, and sport facilities in the Cadet area. The Cadet Chapel has two floors. On the first floor, there are Catholic and Jewish worship halls, and a Protestant worship hall on the second floor. Now, did the brief interview of our building work out? So let's continue talking about the topic of foundations for this week. For better understanding, we brought this part of the land where the Cadet Chapel is located. Well, last time we explored various studies on the land at the USAFA site, discovering that the Cadet area where the Cadet Chapel is located consists of mesic grassland with plenty of moisture and is composed of soft, loose soils with a lot of sloping terrains. In order to start constructing buildings on such sloping, soft land, two types of groundwork were needed. Firstly, the land needed to be leveled, and secondly, measures were required to ensure that the soft ground could support the weight of the structures. Now, among these, let's focus on the first one, the key aspect of leveling, which involves installing a retaining wall. If we just pile up dirt to make it flat, the ground could collapse under pressure or weight, and to prevent this, we need to support the dirt so it doesn't slide down. This wall has supports called counterforts retaining wall, which connects the stem with the heel slabs. The counterfort retaining walls are hidden underground so you can rarely see this structure in public, and they are normally 7 meters tall or even taller. Counterfort walls are enhanced with inclined supports to better distribute soil pressure and support higher loads. This makes them suitable for larger structures. Now, can we apply a retaining wall to all types of land? And if so, how thick and long should it be? Well, we were able to determine this through several tests, such as the boring test, which tests the soil content, and the triaxial test, to test the soil's shear strength, which were shown last week. Now, based on the experiment results, we found out that we can install a retaining wall with a height of 10 meters and a thickness of 1 meter. Shall we go ahead and install the retaining wall? The site is prepared by digging out the area for the wall and laying a strong foundation, which could be made of concrete or compacted gravel. Then, the wall was constructed by pouring concrete into molds, and after the wall was put up, the area behind it was filled with soil and was compacted to make sure it's stable. Finally, the ground is flat. Now let's move on to the second step. In order to build a structure on land, we need to install something underground to make the floor firm in order to support the weight and the pressure of multiple buildings. As you guys already know, we call this something a foundation. As mentioned last week, by comparing many factors related to construction, it seemed better to use deep foundations rather than shallow ones because drilling shafts are cheaper than excavating, and also because it was faster. Now, while cost and speed were important factors in determining the most suitable foundation, characteristics of the Douglas Mesa gravel was the most important. It was shown that the gravel easily captured moisture from groundwater and rainfall, making it difficult for itself to harden, and it made steel rust. In consideration of these facts, deep, open caisson foundations were decided as the most suitable solution. But what are the open caisson foundations? The open caisson is a cylindrical concrete structure with a hole in the middle. It is placed on a soil surface, which is then dug from the inside of the caisson. As more soil is dug out, the caisson gradually drops further into the ground and more caisson structures are stacked on top of it in order to dig deeper into the ground. This caisson method is advantageous in places with lots of moisture because it is partially waterproof. It also has the advantage of being cheap and does not have much depth limitation. These are the reasons why this method was used in the chapel's construction. Now, similar to the retaining wall, the open caisson foundation also required a test in order to determine how deep down into the ground it should be driven into. So the test was conducted on the actual site, in full scale, where 3 holes were dug to install caissons. The weight and pressure on the caisson was gradually increased in order to measure the maximum extent of its creep, in order to know the safety margins of construction. After this test was executed, these results were shown. You can see here that the land below the cadet chapel mainly consists of gravel, pediments, and Dawson Arcos. The test results showed that the gravel and the pediments could not support much pressure. However, the Dawson Arcos, a type of sandstone, was able to handle more than enough pressure and got stronger as they went deeper. So, it meant that our caisson needed to go down as deep as the Dawson Arcos, requiring a depth of about 13 meters underground. Wow! Through the help of retaining walls and caisson foundations, can you believe that the rough bumpy plains were transformed into a stable piece of land, ready to build the cadet chapel? In the next few weeks, we will brief you guys on the structure and construct the cadet chapel. See you guys next time!